Welcome back to the Houdini Beginner series. I'm Suraj V, and if you are new here, this series is built to take you from the absolute zero to actually understanding how Houdini works. In part 1, we looked at the interface, all the panels, what everything does, how to navigate. If you haven't watched that, go watch it first. Link is in the description. Today, we are going inside the network editor. Okay, this is where everything actually happens in Houdini. Every effect, every simulation, every model, it all lives here as a network of nodes. By the end of this video, you'll understand exactly how nodes work, how to connect them, and how Houdini thinks procedurally. Let's get into it. So first of all, I would like to tell you that this is now how your interface is going to look. Actually, I have customized my interface according to my needs. And if you need this kind of interface, you can customize it yourself. Go over here, white color box over here, and arrow on its right. You can click split left and right. The UI would split into two halves, and you can drag your whatever tab you want to, and you can shift by clicking and dragging it. So this is how I like to work. I'm comfortable with this UI more. So let's talk about the network editor. So when I talk about network editor, think of it like a flowchart or something like a recipe. Like if you want to create an effect, like suppose if I want to create Dr. Strange's circular motion effect, right? So how would we create that? So you will think of it as a recipe. So first of all, you will need to create a circle, and you will need to add some effects. You will need to work on volumes. You need to work on particles, everything that. And how it happens is step by step, right? So you start with raw ingredients. Like here, I'm starting with a box. You must have something to start with. Now I would work on this. I would keep working on this box, and this is how anything gets prepared, right? So basic shapes and data points, and you pass them through a series of steps. Okay, each step does something to our data. Like each node I will use will have some effect on my object, on my data, and the final result is what you see in the viewport, right? And I'll play with the values. When I add some nodes, play with the values, the data which is getting calculated by every node, it will be displayed over here, right? Suppose if I drop a transform node and display it over here, let's not display it, and I'll play with the values. I'll translate in the x-axis, in the y-axis, the z-axis. I'll do some rotation. So I'm playing with the data. So this is the display port, right? So when I'll click on display, I would see the result of my data changes. So this is how I this is what is network editor, right? And when we play with the values, how we would play with the values? We would need a node or something like transform, right? So these things, all of these things which would help us in changing the data, we will call them nodes. So this is a node, transform is a node, box is a node, right? And this network editor is where you will build, connect, and manage all of those nodes. This is where you will create destruction. This is where you will create blast. You will create smoke. You will create fire. Anything you will create in this network editor. You will play with the data over here, and that data would be displayed over here, right? So this is so now let's talk about what makes Houdini different from software like Maya or Blender. In those programs, Maya or Blender, if you have been using it, You know that when you move a vertex or apply a modifier, it's done. Like you later cannot change the value, you cannot change the point and anything, and like it's baked in, right? You like it's possible to change the uh, it's possible to change the data, but it's not that easy. When you just move a point, the whole model gets like scattered, right? So you can't easily go back and change the step 3 without breaking steps 4 and 5. So this is where Houdini is different. In Houdini, everything stays alive, everything stays connected. You can go back to any node, change a parameter, and the entire chain updates automatically. Let's take the transform example again. And if I transform the data, I'm transforming my box to the x-axis, the y. Now, if I want to go back and change my data in the box, I want to decrease the size, I want to increase the axis parameters, or I want to change the position of the default box. Later I'll go to transform. It would like pick it up easily. It will change the data easily, right? So because everything is connected through this, because everything is connected, we are connecting everything by a node. We are connecting the output to the input, and whatever changes we do will automatically get updated, right? So let me change the default values, keep it the values to default. So you can go back to any node, you can change the parameter, and entire chain updates automatically, right? That's what procedural means. And Houdini is a procedural software, you must have heard. And this network editor is where that procedural magic lives. Because this is where all the nodes would connect. This is where you would use all the nodes, you would create things. And this is where procedural magic would happen. Okay. So now let's talk about nodes properly. So what is a node? Node is basically just an operation to change some values, to change the data, to change something, right? It takes something in, like we are taking in the value of our box, we are taking the output and putting it into input, and we do something to it, and it passes out over here. That's it. So this is what node is. Every node has inputs at the top and outputs at the bottom, right? So you connect them by dragging a wire from one node's output to another node's input, which we have already learned. Okay. This wire is called as a connection. And this wire carries your data from previous node to the next node. Okay. Now let me tell you something which we have already discussed in the part 1. Like we are still in the beginner series, okay? So let me explain it once again. So suppose there are different nodes in our network parameter. How will Houdini know which node to show in the display tab? Simple, right? It is controlled by something called flags. When I click the blue flag over here, we are viewing the box. When I click the blue flag, the transform, we are viewing our transform. It is easier to explain like this, right? If I display to my scatter, so I will display to this. If I click the blast node, I would be displaying over here, right? Let's take a color. If I click display on my color flag, if I click the blue flag on my color node, then a color node would display, right? So this is what a blue flag means. When we see a blue flag, it means that's what you see in the viewport. Okay. So there's also a purple flag next to it. What is this? It's a render flag or the template flag. Okay. So it's basically a simple template which you would like to see, or like it would help you in some cases just to view the other node. Like if suppose if I put my blue flag on the box and if I click template to my transform, I would see a gray lines template of my box. So I can see how my box would look like. If I click over here, if I change the values, I can see, I can template it, right? And you can also template multiple nodes at one time. Suppose if I'm displaying to the box, I'm templating this transform node. If I also want to template my transform 2, I would press shift and left click on the purple flag. Now I'm templating two nodes, right? So I can template multiple nodes, how many I want, right? But I do not have an option to have multiple blue flags on any node, because blue flag is only one. Like you can only display one node at a time, but you can display multiple templates of nodes at one time. So now there's also a yellow flag over here. Basically means bypass. Like it temporarily turns off that node. Like let's get rid of these nodes, and right now I'm not turning on the bypass flag, this one yellow color. I would just put my display on transform. Now I would put my display on the color. Now we are seeing that, just a second. Now we are seeing that I transform the position of my box to the -3 side, right? Oh yeah. So if I put my display flag on my transform, you can see I shifted my position of the box a little bit towards the x-axis. Now I'm coloring the box. Now what I'll do is I'll click the bypass flag. So what it did is it took data from here. Earlier when the bypass flag was not on, it was feeding the data to my transform and changing the values according to transform node and transferring the new values to my color node. And what I did is when I click bypass, I'm totally ignoring this. I'm directly getting my data from the box to my color. Okay. So if I again turn off the bypass flag, we have again got the transform values. So it in simple language means bypassing, ignoring the node. Okay, so now suppose you're working on a big project, and when you're working on a big project, you will have a lot of nodes. Like this, all of the nodes would fill. Like it's a good thing that we have unlimited node space, but I'm just telling you example that when you're working on a big project, all of this get filled with nodes. Okay, so it gets really difficult to organize. So node networks get bigger, they get very big. Organization becomes so very important. A messy network is a nightmare. Suppose if I work like this, I have all of my nodes like this, right? So it would become very messy. So Houdini gives you a few ways to keep things clean. So first, you can color code your nodes. What you can do is you can select your nodes and click C on your keyboard and you'll get this color tab. Now you can choose whatever color you want and you can color your node accordingly, right? So now second, you can add null nodes as labels. Suppose in the end, suppose if this is my final last node, I've got the result what I wanted to achieve. In the last, you would like to add a null, plug in the output, and just rename it out box. Okay. This null node is blank node, like it has nothing to do, like it is a totally like we cannot say it as a useless. It is just a node which we use usually at the end to have our output name mattering. Like we can name our outputs in a more efficient way this way. Like if I end my nodes network over here, this is not like looks very professional, like I am leaving my end node at the color. But this outbox, when I give my file to someone else, he would understand that okay, this is the last node because I'm writing, because the name of this node is out. Out means the last box. Okay. So now there are some other nodes, some other features also. Like you can group your nodes network together using this network box. Select your nodes and click this network box and double click over here. You can name it box nodes. So I have all my box nodes over here. I can move it anywhere I want to. If I want to delete it, I'll just click it and click it delete. We also have this sticky note. If I take this sticky note, if I want to give my file to someone else, and if I want to organize it more in a more efficient way, I can use this sticky notes and write these nodes are for box. So if I'm giving my file to someone else, it would be easy for him to read. Or if you are opening your file after a long time, these notes can help you understand, right? We also have a background image. So it's basically like you can have a picture over here. Okay. So now there's another trick also. Like if my nodes are scattered like this, what I can do is I can select all of my nodes. I'll click L on my keyboard, and L means layout, and it would lay out for me my nodes easily. Right? Also, if you're working like this, when you will have a lot of nodes, and when you're working, you will have a network which will have this kind of like one node you will have over here, another node you will have over here. So this would look very unorganized. So to tackle this, we have what you will do is you will hold shift on your keyboard and click S. So Houdini has this, it like curves your connection in a more appealing way, if I can say that. Okay. So it's your personal preference if you want to keep your nodes like this or like this. So it's your personal preference if you want to keep your nodes like this or like this. Okay. So now let's delete this box. Let's create a new geometry and let's keep it, rename it to as let's rename it as 2, right? I'll go inside, and now let's put everything together and build a small network from scratch. Okay. So I will give a simple rock scatter. I'll a procedural rock scatter. Okay, nothing fancy, just enough to show how nodes chain together in a real scenario. So let's create a grid. So this is our grid. So This is my ground plane. Okay. Now I'll create a sphere. We have our two nodes. Okay. This is going to be my rock. Okay. So I'll make it a bit smaller, maybe around 0.2. Yeah. This is our rock. This is our ground. Okay. Now what I'll do is I'll create a scatter node. What scatter node do is, like, let's connect the output of our grid into our scatter and display our scatter, and let's see what it does. So what scatter does is generate random points across the surface or whatever the input is. Like if I template my grid, we can see points are scattered all over the grid surface. Okay. This is our grid and we have scattered points on our grid. We can decrease or increase the number of points. We can change the global seed, and you do not need to worry about all of this. The gray intensity attribute, all that we'll discuss in upcoming classes. Or we also have an option for relaxed iterations. So if I have a lot of points, what it basically does is, like over here, all of our points are close to each other, and as I increase the relaxed iterations, our points maintain some distance with each other. Okay, so let's have around 30 points. Okay, so now I want my sphere. So scatter has scattered some points, right? Now I want my sphere, which is our rock, to get scattered to take place of these points over here. So for that, the correct node would be copy to points. I would display copy to points here. What if we are required is geometry to copy. So our geometry which we want to copy is our rock and target points. We have our points on our scatter, so we would put the output to the input of points, right? So let's see. All of our rocks are scattered. There it is. Spheres are scattered randomly across the entire grid. So this is how proceduralism works in Houdini. So now if we created this in Maya or Blender, this would remain this. If I want to create more rocks, to increase the size of rocks or something, then I'll have to work a little harder. But this is not the case in Houdini. If I want more rocks, what I would do is I would go in scatter. I would decrease or increase my points. It would increase or decrease my rocks, right? If I want my rocks to be close to each other, I can. Right? If I want to change the seed, I can. If I want to change the radius or scale of our rocks, I can increase, I can decrease, right? So this is what is procedural modeling. This is what proceduralism is in Houdini. Okay. Change one thing upstream and everything downstream updated. Everything downstream updates. This is how professionals work in Houdini. Not manually placing objects one by one, but building systems that generate results. And that's the network editor. So now you understand what nodes are, how connections work, what flags do, how to stay organized, and how to actually think procedurally. This is the foundation. Everything else in Houdini, simulations, VFX, destruction, fire, everything, it all runs exactly on this system. Just more nodes doing more things. Nothing to worry about. In part 3, we are going deeper into geometry. We'll look at the actual nodes that build and manipulate shapes. We'll start understanding what points, vertices, primitives actually mean in Houdini. If this helped you, subscribe. I post Houdini content every week. Drop a comment if you have a question and I'll answer it. See you in part 3. Thank you for watching. Bye bye.